Hello, welcome to Curry. This is my dorm room in the boys' dorm. I couldn't get the other videos to work, so we're making new ones. Yay! Okay, let's review some glycolysis. People, how exciting is that? I know you're excited. Okay, one more time. I promise. Glucose, through the process of glycolysis, gives us 2-pyruvate. Through this, we're doing a bunch of intermediates. We're making these high electron intermediates, right? The high electron intermediates are these guys here. We get through the Krebs cycle. We're making a few ATPs, but it's minuscule compared to this bad boy here. Once you get down here, we go into the matrix. This is the electron transport chain. These high energy electrons are they have all this energy because of the high energy transfer. They're like, ooh, I have all this energy. What should I do with it? I should throw hydrogens out the window. So they start chucking hydrogens out the window and like, ooh, I have all this energy. They pass it to the next one. They're like, ooh, I have all this energy. What should I do with it? I should throw hydrogens out the window. They start throwing hydrogens out the window. They pass their electron to the next guy. The next guy's like, ooh, I have all this energy. What should I do with it? I should throw hydrogens out the window. At some point, the last guy's like, ooh, I have all this energy. I threw my hydrogens out the window. I got to pass it to somebody. I got to pass my energy to somebody. Who should I pass to? Oxygen. Yeah, and that's why you breathe. Because oxygen is the electron acceptor. It's the high energy electron acceptor. And then oxygen is like, there's all these hydrogens. What do oxygen and hydrogen do? They make water. So the byproduct is water. But this is the whole reason that you breathe. Is so that oxygen can accept those electrons. And at the end of the day, all your hydrogens, here are your hydrogens out here, they're coming back through. So I threw them all out the window, and when they're coming back through, they're like spinning a wheel, like a water wheel. And every time they spin the wheel, it makes an ATP, like click, cling, click, cling, click, cling. And so they're coming back in, they're making ATP, and all that's happening. I can review this again. We'll have a few days of review if you still don't get this, but we got to move on. So that's sort of what's happening. You got your glucose. It's making your high energy electrons. They're getting excited. They're throwing hydrogen out the window. They're coming back. They're making ATP. This is magic. Okay, so this is what happens when you have straight carbs. This is glucose being broken down, starting in your mouth, going through, basically being broken down all the way through. Amylase sort of breaks down the saliva. In your saliva, it starts breaking down. It breaks down into what? Monosaccharides, one of which is glucose, and voila, bada boom, bada bang, we got a bunch of ATPs. Okay. Now, how many of these are? This, I think, is review, actually, for most of you. But I could not remember where we left off. So just in case, you get 4 magic ATPs right there, folks. The remainder is generated via electron transport and oxidative phosphorylation. So the electron transport is, oh, I have a bunch of energy. I'm throwing hydrogens out the window. Oxidative phosphorylation is the process by which you actually get ATP. I will take either one of those answers for anything. You can call it the electron transport chain. You can call it oxidative phosphorylation. You can call it both. I don't care. Based on 3 ATPs per NADH. And I think you get 3 from FADH2. Okay, this being said, this changes. Like, I could tell you something today, it's 32 or 38, and it would change tomorrow. So I don't really care that you memorize this 32, 38. It's 30-ish, between 28 and 30, 20, high 20s, mid 30s. That's what I want you to know, because we're just going to compare it to, say, what you get from fats, and that's going to be a lot more. So I don't need to like, oh, is it 32? Is it 36? Is it 38? That changes every day. So I don't care about that. I care that you know it's like high 20s, mid 30s, and that's going to be a lot less than lipids. Okay, so that is glycolysis. Now, we're going to do something that's not, because as I was preparing the study guide, I remembered the G's. There's a bunch of G's. Not Gullivi, people, because I know that's what you want to do. There's a bunch of them. Let's start with the ones we know. Glucose, okay? Glucose, this is easy. This is like breakdown of carbohydrates, okay? This is easy. Glycolysis, right? This is breakdown of glucose to ultimately, well, ratios of glucose to pyruvate. Let's say that. Okay, so those are the easy ones. We already know this, right? Okay, let's talk about some more super fun G words because it gets messy. And I'm not even joking you with the messy. Okay, glucagon. Let's start there. Glucagon. This is really fun. Imagine a teeter-totter. So I can't draw a teeter-totter because I can't just show you. So here's a teeter-totter. Here's insulin. Here's glucagon. When you have high glucose, you have insulin. Insulin's like, hey, people, there's a bunch of glucose in the blood. Can someone get rid of all this glucose? It's crazy. It's everywhere. You just ate the calf and you went to the place where there's desserts. I know you go there. I know you walk over there and there's cheesecake. And so you have a bunch of glucose. So you had glucose for lunch today or turkey or whatever. Not turkey, but like pumpkin pie or whatever you had for Thanksgiving. Tons of glucose. Insulin's like, boom, get that in the cells, glucose, everything's taking place. Sweet. Okay, now you're sitting in my class at 150. That glucose is gone, folks. It is gone. So what happens? Glycagon happens. Glycagon is what happens. So glycagon is actually a hormone. Let's call it hormone the opposite of insulin. Yeah, that makes sense. So glycagon, do you remember? Okay, here's another word. Do you remember? We made it. What did I do with it? Hold on, let me look for it. Okay, glycagon breaks down glycogen, and I gave you a really pretty picture. Do you remember glycogen? Remember the flour? So you have too much glucose. Your body's like, dude, I don't need this. It's like, that's way too much. Just go make a pretty flour somewhere and store it. So it stores glycogen. Glycogen is the pretty starch flour. I call it a starch flour because that's how I remember it. This thing, the pretty starch flour. Okay? So glycagon, it's like, dude, get the starch flour. Come on. We need some glucose. We're out. We're all done. We stored it all, and now we need some more. So glycagon comes in and breaks down. Do you see? Are you seeing how this is a mess right now? Breaks down glycogen. I'm not even kidding. Glycogen. I'm calling it the starch flour. Starch flour of storage. Starch flour of storage. How did the glycogen get there? I tell you. Guess what? It starts with the G. Glycogenesis. I'm not even making this up. It seems like I am, but I'm not. No, it's with a C. Cogenesis. This is the process. The process to make glycogen. For real. Do you see why I'm separating out all the G's? Because you're going to miss this on a test. I mean, just even when to spell it G-L-Y and G-L-U, it makes your head hurt. So, for real, you have to know this. Okay. Glucose, glycolysis, glycagon, glycogen, glycogenesis. It gets better, people. Now, glycogen. Okay, so we made the glycogen, we got the flour, we got glycagon, which is like, dude, we got to go get the starch flour. How are we going to get that out? That, my friends, is glycogenolysis. Yeah, for real. Glycogenolysis. Yeah. That is the breakdown of glycogen to glucose. Seriously. Then there's one more. There is, this is my favorite because it's the longest. Gluconeogenesis. What's that? That is the process by where we break down lactate. Remember I said that if you are running glycolysis, right? And you're running because you just like running a marathon or you're out working out or doing whatever you're doing, swimming or whatever. You aren't getting enough oxygen to make the whole glycolysis pathway work out the way it's supposed to go. So you instead make lactase. You make lactate. Lactase breaks it back down. You make lactate, you make sometimes other stuff, but gluconeogenesis, that's spelled wrong, gluconeogenesis, breaks that puppy back down. Lactate, amino acids. This is when we talk about proteins, and glycerol. Glycerol breakdown into glucose. And that, my friends, is the G's. That's just the beginning, folks. That's the G's. Okay. I wanted to get those down. I want you to write those puppies down somewhere else, because as we go along, you're going to be like, oh my gosh, there's so many G words. I can't even function with all the G words. So get a piece of paper, put in your notes, write down the G words, okay? Because they're super confusing. They are going to confuse you. I'm sorry. I know that you all are really, really smart, but I'm telling you, these are going to confuse you. You're not even going to know if to spell them G-L-U or G-L-Y. They're that confusing. Okay, I'm gonna stop this one, the G one, and then we're gonna start over because you're gonna have the little list of all the G words. Okay, we're gonna do it in a minute.